Hello, Longhorns. This review right here is from today's lesson, November the 2nd, 2016. And I made this recording so that those of you who were retesting or those of you who are absent will know what we did in class today and will be able to fill in your notebook notes. This is on page 151 of your pre-cal notebook. If you want to turn to that page right now, I'm going to go ahead and simplify and work out the odd problems on pages 151 and 152. It's up to you to complete the even problems. So first of all, we're looking at some radical expressions, and we're supposed to combine them by subtracting. Well, first of all, as you can see here, this radical expression right here and this radical expression right here do not match. So we have to make sure that they are a common radical before we can combine them. So I'm going to simplify this radical. So first, I'm going to go ahead and take my -3, and I'm going to multiply that times the square root, and I can break this 27 down into 9 times 3. And I notice that 9 is a perfect square, so I can take the square root of that, and that's what I'm going to do. I'm going to take the square root of the 9. So now I'm going to have -3 times 3 times root 3 minus 3 times root 3. So now at least now I have a common roots, which makes it a little easier for me because now I can combine things. All right, so let me go ahead and finish. I'm going to go ahead and finish combining this right here as multiplication. -3 times 3 is -9 root 3 minus 3 root 3. And I know that -9 minus 3 is -12. And I have a root 3. And that is my answer for number 1. Okay, now let's look at number 3. Here we have a radical in the denominator. I'm going to go ahead and simplify that first. So I have a 5 root 2 in the numerator and a radical 18 in the denominator, but I'm going to go ahead and simplify that to 9 root 2. 9 times 2. I can take the square root of 9. That's going to give me 3 root 2. And now right here what we can do, we could rationalize the denominator, but it's not really necessary because we have a root 2 in the numerator and a root 2 in the denominator. So we're just going to simply cancel them out. And so our final answer here is going to be 5/3. And that's all there is to number 3. Okay, for problem number 5, you'll notice that we also have a radical in the denominator. However, it's got a +2 with it. So because our radical root 2 plus our number 2 is together combined, we have to count that as one term. We cannot just rationalize the denominator here with the root 2. So what we're going to have to do is we're going to have to use its conjugate. So we're going to multiply this times its conjugate, which is root 2 minus 2. And I'm going to go ahead and put these terms in parentheses. And so since I use that in the denominator, I have to use it in the numerator as well. Okay. So now we have to FOIL this denominator. So what happens when we FOIL the denominator? Well, we get this right here. Root 2 times root 2 is 2. Then we have a +2 root 2, a -2 root 2, and then we have a -4. Well, these middle terms simply cancel out, and we're left with 2 minus 4, which is a -2. So that's going to be in my denominator, that -2. So now I have 2 times root 2 minus 2 in my numerator, and I have a -2 in my denominator. So in my numerator, I'm going to need to distribute. All right, I have to multiply this 2 by root 2 and 2 by -2. And when I do that, I get 2 root 2 minus 4 all over negative 2. So my last step for this one is to simplify this very last rational expression, and I'm going to divide 2 by negative 2. That gives me negative 1. So I have a negative root 2 minus, and then negative 4 divided by negative 2 is just positive 2. And that's going to be my final answer for that one. Okay, for problem number 7, we are going to distribute this 3 root 3. And so when I do that, I get 3 times 3 is 9 root 3 plus, and then 3 times 3 is 9 again, root. And now I'm going to multiply these roots together. So when I multiply these roots together, I actually get root 18. Now, if you notice that these roots are not the same, so we cannot combine them. So I also noticed that my root 18 could be simplified. So I'm going to go ahead and simplify that. So I have 9 root 3 plus 9 root, and this could actually be changed to 9 times 2. So I'm going to change that. Now I have 9 root 3 plus 9 times 3 root 2. And then we have 9 root 3 plus 27 root 2. Well, if you notice right here, what happens is we have a 9 root 3 and a 27 root 2. These roots are not the same. So since they're not the same, we cannot combine them. So we are finished. Put a box around it and we're done. Okay, in this next section, problem number 9, we're going to write each expression in radical form. So I'm going to do number 9 and you're going to do number 10. And I'm going to make this a little bit bigger so you can see it better. All right, so remember that roots of a tree are at the bottom of the tree. Same thing with radicals, okay? Our root is going to be in the bottom of our fraction that represents our rational exponent. So if I'm rewriting this in radical form, I'm going to write my radical. My root number, which is my number 5, is going to go into the little notch. Okay, so this is going to be a 5th root of 3a. 3a goes inside the radical, and then I'm going to put parentheses around that, and I'm going to raise it to the 3rd power. The 3 is my exponent. All right, for number 11, we're going to write each expression in exponential form. I'm going to do number 11, and you're going to do number 12. So looking here at number 11, we're doing exactly what we just did, except in reverse. Okay, remember I said that this 5 right here, that's our root, and roots go in the bottom, just like on a tree. So I'm going to take my x that's inside my radical. I'm going to put that root 5 in the denominator of my exponent, and the 3 goes on top. Now, the one thing you have to remember on this, make sure that you're writing this 3/5 rational exponent as an exponent, okay? Do not write it like this. This is not correct. Okay, in the next section, problems 13 and 15, you're going to do problems 14 and 16 on your own. For this section, we're doing simplify, and that your answer should only contain positive exponents with no fractional exponents in the denominator. All right, so here we go. First of all, we're going to do number 13. So I'm going to expand that out so you can see it a little bit better. If you're using your phone, it'd be easier to see if I expand it out, so I'm going to expand it out. All right, so our base here for our exponents is n. So I'm going to keep this 4 as this is a coefficient, so that's just going to stay as a 4. So I'm going to write down my 4. Let me change colors. I don't want that to be red. Okay, we're going to write down our 4. Okay, and then our n is our base, so we're going to keep our base. Now, when we're multiplying two numbers that have a common base, we add the exponents. So over here on the side, I'm going to go ahead and add these two fractions together. You can also do this in the calculator. And what you get here, if I do it by hand, I have to find a common denominator. So my common denominator is going to be 12. So negative 1/3 is going to become negative 4/12. And 5/4 is going to become 15/12. And when I add those together, I get 11/12. So my answer is going to be 4n to the 11/12. And that's all. Okay, so for problem 15, we have a couple different things going on here. First of all, we have our base p that is raised to another power. So remember, the rules of exponents say that if we have a power raised to another power, that we multiply those exponents together. So let's go ahead and do that. We have p to the 3/2 times negative 1/3. So I'm going to do that over here on a scratch on the side here. 3/2 times a negative 1/3. That's going to give me a negative 3/6, which reduces to negative 1/2. So let's keep that. Negative 1/2, we're going to put that here as our exponent. And then we're still multiplying times p squared. All right, so now we're back to the other rule that says if we have a base, a common base, we add the exponents if we're multiplying the bases. So we keep the p, and we're going to add the negative 1/2 to the 2. And we end up with a 3/2 as our exponent. Okay, finally, I want to give a shout out to Ashley Sterling and to Lauren Galvan for helping me today correct all my errors in class. So if you notice that your notes are slightly different from what is on this video clip, then you'll see that those errors have been corrected. So just go ahead and correct them in your notes. And again, thank you, Ashley and Lauren, for helping us today, keeping everything perfect. Thank you so much.